In this video, we find the equation of a linear function in slope-intercept form given 2 points on the line. So here's the example. It says find the equation of the line that contains the points -5, 1 and 5, 3. So this is just, we're given 2 points, right? -5, 1 is go over -5, up 1. There's a point over here, and then there's a point over it. Go over 5, up 3, go over 5, up 3. So we're just being given 2 points on the line, and our job is to find the equation of the line that contains those 2 points. You don't need to see the picture to know what you can be given the points without needing to see the picture. You can always get a quick sketch of the picture if you want to. The idea is that we know that a linear function in slope-intercept form has the form f of x equals mx plus b. And in a previous video, we went over how to calculate the slope of the line. We know it's just rise over run. So we calculate the difference between the y coordinates divided by the difference between the x coordinates to calculate slope. It's rise over run, or change in y divided by change in x. So to calculate the slope of our line, I just grab the 2 points and I say, hey, the function ends at a height of 3 in the y direction, but it started at a height of 1 in the y direction. So the change in y is going to be the y value where it ended minus the y value where it began. So it's going to be 3 minus 1 is our change in y. And then the change in x is going to be the x coordinate where I ended minus the x coordinate where I started. So 5 minus -5, and then we can calculate the slope of the line. 3 minus 1 is 2. I have a double negation, so it's really 5 plus 5. So we get 2 over 10, which is a fifth, and there's the slope of the line. If you're using the formula for the slope that says y2 minus y1 over x2 minus x1, if you're taking a formula approach to it, you need to assign one of these to be x1, y1, and one of them to be x2, y2. So for example, you could say x1, y1 equals -5, 1. And then you could say that x2, y2 equals 5, 3, and then you could just plug things into the formula, right? y2 is 3 minus y1 is 1 over x2 is 5 minus x1 is -5. But you can see that doing it this way, you have the same thing that I had right here, just by reasoning through what does rise over run mean, or change in y divided by change in x. So we get a slope of 1/5. Once you get the slope, you go to the equation, f of x equals mx plus b, and you replace the m with the slope that you calculated. So we get f of x equals 1/5 x plus b. And then you grab either of the 2 points. Either of the 2 points, it doesn't matter which one. So grab the one that makes you happiest. This point makes me happier than this one does. I'm going to avoid using the negative number just because, but it's really kind of irrelevant. So I'm going to grab this point, and this point says, hey, when x is 5, f of x is 3. So here I'm going to take my f of x, I'm going to replace it with the output of 3 and say 3 equals 1/5 times x. But when y or f of x is 3, then x is 5. And then I go plus b. And 5 times a fifth equals 1 plus b. So I subtract 1 from both sides and I get 2 equals b. And then I want to update my equation with f of x equals 1/5 of x plus 2. So there's my equation. Had I used the other point to try to calculate b, I would have gotten the same result. So if we take a look at this, we could also have said right here, we could have we calculated the slope. So we could have said, hey, when the output is 1, when f of x is 1 equals 1/5 times x. When f of x is 1, x is -5, so we would have gone times -5 plus the b that we don't know yet. And then I would get 1 equals 1/5 of -5 is -1 plus b. Then I would need to add 1 to both sides. I'd get 2 equals b. And what you can see is that it didn't matter the point that I selected to calculate b. I get the same result regardless. So I don't need to worry about which one is which. In the same way that we don't have to worry about which point we make x1, y1, it's irrelevant as long as we're consistent and have the, if this is y2, then this better be x2 right here. If this is y1 right here, then this better be x1 right here. We just need consistency and we're good to go.